In this example, we're going to use transformations to graph an exponential function, or an exponential equation. The equation is y equals negative 3 raised to the x plus 4 power. In this case, of course, we're taking 3, raising it to the x plus 4 power, and then taking the additive inverse of the result. There are two transformations that are actually occurring here. There's a horizontal shift. This is actually shift to the left. By 4 units. If that plus 4 had actually been not in the exponent, but down here, say you had negative 3 raised to the x, and then the plus 4 were down here on the same line as the negative 3 to the x, then you would have a shift upward. So the idea here is that anything that happens inside the exponent is going to cause a horizontal change in the graph. Let me turn off this light. I don't know if this will help. Yes, that does help actually, I think. Okay, so we have a shift left by 4 units. And then, of course, the minus in front of the 3 that causes a reflection. Across the, oops, not y, my bad, x-axis. And I'm going to start with the parent graph. The parent graph is going to be the graph of y equals 3 to the x. And that graph contains the points, let's see if I can get some better colors than this. 1 second. Okay. The parent graph contains the point 0, 1. And when x is 1, y is 3. It goes like this. I really don't like these Crayola pencils. They're not very bold. Can you see that? Well, it looks visible for the most part. Okay, so there's the parent. And now what I want to do is go ahead and by the way, remember that the x-axis is horizontal asymptote for any basic exponential function, like y equals 3 to the x, or y equals 2 to the x, or y equals 17 to the x, some number raised to the x. So I'm going to shift left 4 units. So I take this point and I shift left 4. And same thing here. And what happens to the asymptote? What happens to the x-axis if I shift it to the left 4 units? Well, every point gets shifted to the left, but the end result is the x-axis. Points get moved around, but when all is said and done, the line's the same. So this right here is the graph that I get when I shift left 4 units. Now I want to do reflection across the x-axis. Let's see, how about this bluish color? So take this point, reflect across the x-axis. Take this point, reflect across the x-axis. Ooh, the lead just broke. Old Crayola. The good thing about these is that these pencils is that they actually are erasable. Who cares if the quality is crappy though, right? Anyways, here's the end result. This is the final graph. Notice that incidentally, when I reflect across the x-axis, notice that the asymptote doesn't change. Really, the only thing that's going to change of all the transformations that we deal with in this course, the only transformation that would change the horizontal asymptote is a shift up or down. If you have a shift up or a shift down, then there's definitely going to be a change in the asymptote. Otherwise, the asymptote is going to remain the x-axis.